Episode 9, Fetch, Decode, Execute, the heartbeat of every computer. Hi, I'm Foggy Michael, and welcome to Computers Before the Internet. Last time, we went inside the CPU and discovered tiny storage locations called registers. Today, we are going to answer an even bigger question. How does the CPU know what to do? The answer is surprisingly simple. Someone gives it instructions. Think about following a recipe. If you're baking bread, you don't execute the entire recipe at once. You read one step, then you do it. Then you read the next step. Computers work exactly the same way. A computer program is simply a long list of instructions. Each instruction tells the CPU to perform one very small task. For example, add these two numbers. Move this value into memory. Compare these two values. Jump to another instruction. Print one letter on the screen. Each instruction is very simple, but when billions of them are performed every second, amazing things happen. Here's something interesting. Programmers usually don't write instructions in machine language. Years ago, many programmers used assembly language. An assembly instruction might look something like this. These words make sense to people, but the CPU cannot read words. It only understands zeros and ones. So another program, called an assembler, translates those instructions into machine language. Now the CPU can finally understand them. So what happens next? Every processor, whether it's an IBM System 360, a modern desktop computer, or the phone in your pocket, repeats the same three steps over and over and over again. Step 1, fetch. The CPU goes to memory and fetches or retrieves the next instruction. Think of it as picking up the next line of a recipe. Step 2, decode. The CPU figures out what the instruction means. Should it add numbers, copy data, compare values, jump somewhere else? The CPU decides exactly what needs to happen. Step 3, execute. Now the CPU actually performs the instruction. If it's an addition, the arithmetic logic unit, or ALU, does the math. If it needs registers, the registers are used. If the answer belongs in RAM, the CPU writes it back. Then, without stopping, the CPU immediately fetches the next instruction. It starts all over again. Fetch, decode, execute. Fetch, decode, execute. Billions of times every second. Think about reading a recipe. Read one step. Understand it. Do it. Then move on to the next step. That's exactly how a computer works. Back in my IBM days, I never actually watched the CPU do these things. Nobody could. They happened far too quickly. But every program we wrote, every payroll, every inventory report, every billing program, depended on this cycle working perfectly. Without it, the computer simply would not run. Here's something amazing. Although computers today are millions of times faster, The basic idea hasn't changed. Every computer you have ever used, from a room-size IBM mainframe to the smartphone in your pocket, still follows the same 3 steps. Fetch, decode, execute, over and over and over again. Next time, we will discover how programmers learned to stop writing programs in machine language and started writing in languages that humans could actually understand, like COBOL, Fortran, BASIC, RPG, or C++. I'm Foggy Michael. Thank you for watching Computers Before the Internet.